What happens if you fall into a black hole? It's one of the most fascinating and terrifying questions in all of science. These mysterious cosmic objects are some of the most extreme things in the universe. Regions where space and time collapse into something our brains aren't really equipped to understand. And yet, thanks to modern physics, we can paint a pretty good and truly mind-blowing picture of what might happen if you were to fall into one. Let's start at the beginning. What exactly is a black hole? Contrary to popular belief, black holes aren't giant holes sucking everything up like a vacuum cleaner in space. They're incredibly dense remnants of massive stars that have collapsed under their own gravity. If you compress enough mass into a small enough space, gravity takes over. The escape velocity, the speed you'd need to fly away, becomes faster than the speed of light. And since nothing can go faster than light, nothing can escape. That's what makes a black hole black. Not even light can get out. The boundary around a black hole is called the event horizon. Think of it like the point of no return. Once you cross it, you're done. There's no going back, no way to signal the outside world, no way to avoid what's coming. But what happens during the fall? Let's imagine you're in a spaceship heading straight toward a black hole. At first, as you approach, things seem surprisingly normal. The black hole just looks like a dark circle against the background of stars. No swirling chaos, no dramatic music. From far away, gravity still behaves like it would around any other massive object. You orbit, you approach, you accelerate. But the closer you get, the stranger things become. If you're falling into a stellar mass black hole, one with a mass a few times that of our sun, you're in trouble early. As you get close, the difference in gravitational pull between your head and your feet becomes extreme. Your feet, being closer to the black hole, feel a much stronger pull than your head. The result? You get stretched. Dramatically. This is what physicists actually call spaghettification. You become a long, thin noodle of atoms, pulled apart by gravity itself. It's not a gentle process. It's not even instant death in the normal sense. In fact, if you're falling feet first, your brain is still technically intact, long enough to know it's being turned into pasta. Charming, right? Now, if instead you're falling into a supermassive black hole, like the ones at the center of galaxies, millions or even billions of times more massive than the sun, things play out a little differently. Because these black holes are so massive, their event horizons are much farther from their centers. That means the tidal forces, the difference in gravity between your head and your feet, are much gentler at the horizon. You could, in theory, cross the event horizon without noticing a thing. No stretching, no drama. From your point of view, it would be completely normal. You just keep falling. But to someone watching from the outside, it would look very different. As you approach the event horizon, time appears to slow down. Your fall looks slower and slower, and your image becomes dimmer and redder, stretched out over time. Eventually, from their perspective, you just freeze. A ghostly, faded image hovering at the edge of the black hole, never quite crossing it. Of course, that's only what they see. From your point of view, time continues as usual. You cross the event horizon and keep falling inward. At this point, escape is no longer possible. You can't turn around. You can't send a signal. Every path forward leads you closer and closer to the core. The singularity. This is where things get seriously weird. According to Einstein's theory of general relativity, the singularity is a point of infinite density, a region where the laws of physics as we know them completely break down. Space and time themselves become meaningless. Distances shrink to zero. Time stops. And anything that reaches this point, including you, is gone. But here's the twist. Modern physics disagrees with this idea of a singularity. Infinite density? That sounds more like a math problem than a physical reality. Physicists believe that general relativity, while extremely accurate in most cases, doesn't work in extreme environments like the core of a black hole. That's where quantum physics has to come in, and that's when things get even stranger. In the 1970s, Stephen Hawking discovered something groundbreaking. Black holes aren't entirely black. They emit tiny amounts of radiation now known as Hawking radiation. This means black holes can slowly lose mass and energy over time. In other words, they can eventually evaporate. So now we face a paradox. If things fall into a black hole and the black hole evaporates, where does all that stuff go? Does it get destroyed? That would violate one of the most important principles in quantum mechanics. The idea that information can't just vanish. This is known as the black hole information paradox, and it's one of the biggest unsolved puzzles in physics. Some theories suggest the information is somehow encoded on the surface of the event horizon, like a hologram. Others propose that when a black hole evaporates, the information comes out slowly, scrambled in the Hawking radiation. And some think maybe black holes aren't the end at all, but doorways to other parts of the universe, or even other universes. What's really happening? We don't know. We're trying to unify general relativity and quantum mechanics into one theory of everything, a quantum theory of gravity, that could finally explain what happens inside a black hole. But until then, we're left with guesses, thought experiments, and equations that push the limits of our imagination. So, what happens if you fall into a black hole? If it's small, you're stretched into atomic spaghetti. If it's supermassive, you might glide through the event horizon without even knowing it, before being torn apart or erased by forces we don't yet understand. Your experience would be unlike anything a human mind has ever known. And your story would end in a place where space, time, and the known laws of physics collapse into a singular mystery. In a sense, falling into a black hole is the ultimate scientific cliffhanger. You wouldn't just be lost to space, you'd be lost to our understanding of reality itself. If you enjoyed this journey into the darkest depths of the cosmos, hit that like button and subscribe for more mind-bending science videos. What mystery should we tackle next? Let us know in the comments. Until then, stay curious, and maybe don't fall into any black holes.